In this video, we're going to build a flexible budget and then use that flexible budget to create sales volume variances and flexible budget variances. We're back to the outdoor outfit company and we're looking at the women's jogging suits. The actual results are still in column B, but I've moved the static budget results over to column H, and I've added a couple of extra columns in the middle so that we can build these various budgets. We're going to start with the flexible budget. The only difference between the flex budget and the static budget is that the flex budget uses the actual number of units sold. But then it goes back and it picks up all of the standard prices, costs, and input quantities that were used in the static budget. So let's slide over here and look at what our per unit costs, prices, and input quantities are. We want to express that in dollars. So you remember that our selling price is $105. Our direct materials was budgeted to be $6 per yard, 3.5 yards per unit, or $21 total per unit. Direct labor was budgeted to be $18 an hour, 2 hours per unit. We didn't talk about where the variable manufacturing overhead numbers came from before, but it works out to be $8 a unit, and that's actually applied at a rate of $4 per direct labor hour, 2 direct labor hours per unit. The total variable costs are $65 for 1 unit. And so if I take the selling price less the $65, I end up with a contribution margin per unit of $40. Now notice my box stops here. I'm not going to come down and calculate a per unit amount for fixed overhead because fixed overhead shouldn't change when my volume changes. For that matter, we can go ahead and just fill in this box right now. $60,000 is where it should be. There'll never be a difference between the flex budget and the static budget. Let's go on up here to revenue and fill this in. If I take 12,000 units times that $105 per unit, I get $1,260,000 for revenue. That's how much revenue I should have gotten if I sold the 12,000 units I actually sold at the standard price. We're going to do the same thing down here. Take the 12,000 units times the $21, and that gives us $252 for direct materials, $432 for direct labor, $96 for variable manufacturing overhead, and my total variable costs are $780,000. My contribution margin I can get either by taking my flex budget revenue and subtracting my flex budget variable costs, or by taking the number of units sold in the flex budget times the contribution margin per unit. Either one of those is going to give me $480,000. I can subtract the $480,000 minus the fixed costs of $60,000, and I get $420,000. So my gross margin should have been $420,000 if I sold everything at the standard price, used exactly the right quantity of inputs, and all of those inputs were at their standard cost. Of course, we can see that that's not what happened. But before we go back and compare this to actual, let's do our sales volume variances. Now, these variances are only variances because there was a different number of units sold. Of course, we know that there were 2,000 additional units sold and that should give us a favorable variance if everything else was at its standard price, cost, and quantity. The revenue variance is $210,000. This is, of course, favorable as well. Now, there's two ways I could have gotten that. I could have taken the flex budget revenue and subtracted the static budget revenue, or I could have taken the 2,000 units, additional units that we sold, times that standard price of 105. Either of those would give me that dollar amount. We're going to do the same thing with direct materials. 2,000 units times $21 is 42,000. Alternatively, I could have subtracted my flex budget minus my static budget. This is an unfavorable variance, but it makes sense. I made 2,000 additional jogging suits. I needed $21 per jogging suit more of materials, so I needed $42,000 additional dollars to make those jogging suits for direct materials, $72,000 for direct labor, and $16,000 of applied manufacturing overhead. The sales volume variance for total variable costs can be derived two ways, again as usual. I could have taken the total variable costs from the flex budget minus the static budget, or I could have summed each of those unfavorable variances: direct materials, direct labor, and variable manufacturing overhead. When I come down to the contribution margin, I have an $80,000 favorable variance. That makes sense. This time, there are three ways to get there. I could have subtracted my flex budget contribution margin minus my static budget contribution margin. That would give me the $80,000 favorable variance. I could have taken the $210,000 favorable revenue variance, sales volume variance, and netted it against the sales volume variance for total variable costs. Or I could have taken the 2,000 favorable extra units that I sold, multiplied it by the $40 per unit contribution margin. There is never going to be a difference between the flex budget and the static budget for fixed manufacturing overhead. And so when I subtract, I have the same sales volume variance for gross margin as I do for contribution margin. Never going to be a sales volume variance for fixed manufacturing overhead. Okay, so this makes sense. I made 2,000, or I sold 2,000 extra units at $40 a unit contribution. I should have had $80,000 additional contribution to margin, additional gross margin. And so that's my sales volume variance. Those variances are only because we sold 2,000 units more than we had planned. To figure out why our gross margin is actually lower than our budgeted gross margin, we need to look at our flexible budget variances. Now, for the flex budget variances, we're going to take the difference between the flex budget and the actual results. And of course, there will never be a difference in the number of units sold because the flex budget has been adjusted to the actual number of units sold. However, there can be a difference between the revenues. This is a flex budget revenue variance, or sometimes called a flex budget price variance, because the only way you can have a difference on this row is if you sold your units for an average price that is different than the budgeted average price. So we had budgeted to sell units for $105 a unit. We must have sold them for more than that because we have a favorable variance here. And you could figure out how much we actually sold them for. Let's just do that real fast. We have $1,320,000 of revenue, and we sold 12,000 units. So we sold them for an average price of $110 instead of $105, and that gives us that different amount of revenue. The direct materials variance, if we look, the actual results are higher than the flex budget by $9,000, and that's an unfavorable variance. Now, this means that we spent $9,000 more on materials, either quantity or the cost of the materials, than we should have to make 12,000 units. So not only is it more than we should have spent to make the 10,000 units we had planned to make and sell, but it's more than we should have spent to make the 12,000 units that we did make and sell. Same thing for labor. We used $138,000 more labor than we should, and our variable manufacturing overhead is also higher than it should be. Again, I can sum three unfavorable variances. If I had a favorable variance in there someplace, I would need to net it, but I'm going to sum these, or I could just take the difference between the actual results and the flex budget. The contribution margin variance for the flex budget, again, I can take the difference between the flex budget and the actual results, or I could take my favorable $60,000 revenue less my unfavorable $161,000 of total variable cost flex budget variance. Either one gives me $101,000 unfavorable. And then we also have a fixed manufacturing overhead variance in the flex budget column. This one is favorable, but again, remember that favorable does not necessarily mean good. We're going to go back and talk about that variance later. The gross margin variance then is $96,000 unfavorable. And so now we have our flex budget variances. So we have an extra column. And let's add together our variances. So if I add together my flex budget variance and my sales volume variance, I get 2,000. That's a favorable variance. Just going to go ahead and add favorable in there. We can add together the favorable revenue flex budget variance and favorable sales volume variance. That is also going to be favorable. We can do the same thing for direct materials, direct labor, variable manufacturing overhead, and total variable costs. So I am just adding the flex budget variance and the sales volume variance. Of course, those were all unfavorable. Now, on the contribution margin variance, we have $101,000 unfavorable in the flex budget column and $80,000 favorable in the sales volume variance column. So we need to net those. And that's $21,000. There was more unfavorable than favorable. So I took $101,000 minus $81,000 gives us $21,000 unfavorable. Of course, for the fixed manufacturing overhead, we only had the one. And then we have an unfavorable and a favorable variance again down here for gross margin. We need to net those. We end up with $16,000 unfavorable. Let's go ahead and copy these two columns and move back to this static budget variance that we did before. And I'm just going to copy those columns and paste them right here. And look what we've got. The static budget variance is the sum of the sales volume variance and the flex budget variance. So you can see how the numbers in column F are the same as the numbers in column C. We'll explore more about this in the next video.